2021, Grade 12, AMC 12A, Fall, questions 1 through 10. Problem number 1. What is the value of 2112 minus 2021 all squared over 169? Well, it looks like we can do this with the calculator, but we're not allowed calculators, so I guess we have to do it manually. So we've got that on the top and this on the denominator, and that's all squared. That becomes 91 squared over 169. Now at this point, we can factor into its prime factors, 13 times 7, and this is just 13 times 13. But remember, that was all squared. So really what this is 13 times 13 times 7 times 7 times 13 times 13. And look what happens. That cancels with that, and all you're left with is 7 times 7, which is 49. Therefore, the answer is C for number 1. Problem number 2. Menkara has a 4x6 index card. If she shortens the length of one side of this card by 1 inch, the card would have an area 18 square inches. What would the area of the card be in square inches if she shortens the length of the other side by 1 inch? So initially, I'm assuming that you have this 4x6 and she's shortening this side by 1 inch. So now it becomes a 3x6. So if it's a 3x6, that is 18, and that's how they got that 18 square inches. So basically what they're saying is, instead of doing that, you now shorten this side by 1 inch to make it a 4x5 card. And if you do that, then of course the area would be 4 times 5, which is 20, and therefore the answer is E. Problem number 3. Mr. Lopez has a choice of 2 routes to get to work. Route A is 6 miles long and his average speed is 30 miles per hour. Route B is 5 miles long and his average speed is 40 miles per hour, except for a 1/2 mile stretch in a school zone where his average speed is 20 miles per hour. How many minutes is Route B quicker than Route A? Okay, so we have Route A and Route B. And speed is equal to distance over time, the standard formula, or any variation of that formula, such as time is equal to distance over speed. Okay, so in the first scenario, we have the distance is 6 and the speed is 30. So therefore, the time would be distance over speed, which is 6 over 30, which is 1 over 5. And remember, this is in hours, so that would be, what, 12 minutes? Yeah. Okay, the next route is a little bit different. It's 4.5 miles at 40 miles per hour, not kilometers. And then you have a 1/2 mile stretch at 20 miles per hour. So this time we have 2 times, time 1 and time 2. This is time 1 and this is time 2. So time 1 is 4.5 over 40, and time 2 is 0.5 over 20. And if you get a common denominator, this looks like 4.5 plus 1 over 40, which is 5.5 over 40. And that is what? 8.25 over 60. And therefore, that is 8.25 minutes. So they want you to compare this to this. And that looks like a difference of 3.75 to me. Minutes. And therefore the answer would be B. Problem number 4. The 6-digit number 20210A is prime for only 1 digit A. What is A? Okay, let's just work with the answer choices here. The first one would make it 202101, and this is divisible by 3. So that can't be prime if you put that one in. If you put 3, it becomes 202103, and this is divisible by 11. So that one's wrong. This one, 202105, that's obviously divisible by 5, so that's not a prime. If you use the 7, it becomes 202107, which is divisible by 3. Therefore, that one, so I guess the answer is E, but that's because 202109 is a prime number. and that's exactly what they wanted. So there you go. Number 4, the answer is E. Problem number 5. Elmer the emu takes 44 equal strides to walk between consecutive telephone poles on a rural road. Oscar the ostrich can cover the same distance in 12 equal leaps. The telephone poles are evenly spaced, and the 41st pole along this road is exactly 1 mile, 5280 feet from the first pole. How much longer in feet is Oscar's leap than Elmer's stride? Okay, so Elmer, he, from the first pole to, I guess, the last pole, which I guess in their case is the 41st pole, takes 44 strides. Okay. And then the other guy, his name is Oscar. Yeah, Oscar. And he's doing the same route, but 12 leaps is how long it takes. Okay. So they're asking to compare the leap and a stride. Okay. Well, this entire route, they've told me, is 1 mile, which is 5280 feet. Okay. Now, 5280 feet, and this is the first pole, and this is the 41st pole. So that means if you you would have how many of these intervals, I guess, is what I'm asking. We'd have 40. Correct? So I just want to figure out the distance between each pole, because the distance from here to here would therefore be 5280 divided by 40. Not 41, because there's 41 poles, but there's 40 intervals. And that number is what? 528 divided by 4 is 132. Okay, so that's 132 right there. Okay, so now all we have to do is figure out the length of each stride and the length of each leap. Now, I think I think I might have made this a little bit confusing for you guys. The 44 strides, it takes 44 strides to walk between consecutive telephone poles. So basically the 44 strides is really referring to just between 2 consecutive telephone poles. I think you might have thought that I meant the whole way. And similarly, the 12 leaps is the distance between 2 consecutive telephone poles. Okay, so the distance is 132, and it takes 44 strides. So each stride is 3 feet. So that's each stride. And then similarly for the leaps, we've got 132 divided by 12, which is what, 12? 11. 11 is the answer. So that means 11 feet is the distance for each leap. So they're asking how much longer is a leap than a stride. Well, a leap is 11, a stride is 3. So a leap is 8 feet longer than a stride, and therefore that is B for number 5. Problem number 6. As shown in the figure below, point E lies on the opposite half plane determined by line CD from point A, so that CDE is 110 degrees. Point F lies on AD, so that DE is equal to DF. ABCD is a square. What is the degree measure of angle AFE? Well, let's take this one step at a time. They've already told me that that's 110 right here. So this is a square, so that's 90 degrees. So therefore this angle right here, which is angle FDE, would be the entire circle, which is 360, minus that 110, minus that 90. And that is 160. Now, they told me that DE is equal to DF. DE is equal to DF. So that's an isosceles triangle. Therefore, this angle and that angle, this angle there and that angle there, will be equal. So let's just call them X. So that means in that triangle, FDE, 2X plus 160, that angle FDE, is equal to 180. Correct? So therefore 2x is equal to 20, x is 10. So put the x is equal to 10. And then finally they want angle AFE like that. So that's going to be just 180 minus 10, which is 170. And therefore That is D for number 6. Problem number 7. A school has 110 students and 5 teachers. In the first period, each student is taking one class and each teacher is teaching one class. The enrollments in the classes are 50, 20, 25, 5. Let T be the average value obtained if the teacher is picked at random and the number of students in the class is noted. Let S be the average value obtained if a student was picked at random and the number of students in their class, including the student, is noted. What is T minus S? So after carefully reviewing this question, T is calculated as follows. 50 times the probability that it happens, which is 1 over 5. And then 20 times the probability that that happens, which is 1 over 5, right? Because T is the average value obtained if a teacher is picked at random and the number of students in the class is noted. So you're choosing a teacher at random, and there's 5 teachers, so each teacher has a 1/5 chance of being chosen. And then the number of students in her class, or his class, I don't know if that's male or female, are listed there. So 50, 20, 20, 5, and another 5. So that's basically the calculation for T. And when you crunch out these numbers, you get 20. Now S is a little bit different. S is right here. Average value obtained if a student was picked at random and the number of students in their class, including the student, is noted. So this time it's a little bit different. The probabilities are now going to be involving the students. And there's 100 students. So that's 50 over 100 for this guy right here. And the number of students is 50. For the next one, it would be 20 over 100. And the number of students is 20, this one. And similarly, you guys get the point. So you just got to read the question a little bit carefully to ensure that the T and the S are calculated properly. And once you do, then pretty much the question is, easy. When you calculate S, you get 33.5. So they want T minus S. Okay, T is 20, S is 33.5, and therefore this is minus 13.5, and that would be choice B for number 7. Number 8, let M be the least common multiple of all the integers 10 through 30, inclusive. Let N be the least common multiple of M, 32, 33, 34, 35, 36, 37, 38, 39, and 40. What is the value of N over M? So for this question, I'm actually going to do it the complete way, explaining everything, because if I do shortcuts, you may not understand it, and that would therefore be pointless. So just bear with me. So M is the LCM of those numbers, correct? And N is the LCM of M, along with 32, 33, ... all the way until you get to 40. Okay, so I'm assuming you know how to calculate the LCM. LCM you calculate, and I'll put this in brackets, choose the biggest. That's sort of the slogan for this question. Choose the biggest. And I think you'll understand what I mean once I start explaining. It's kind of counterintuitive because it's least common multiple, but you choose the biggest. Okay, well, let's see. So as I said, I'm going to do it the long way. So first let me write out all the numbers from 10 to 30. And there you go. Now my task is for each of these numbers, I've got to put their prime factorization. So for example, this is 2 times 5. This is just 11. This is 2 times 2 times 3. This is just 13. This is 2 times 7. This is 3 times 5. 2 to the power of 4, just 17. 2 times 3 to the power of 2, 19. 2 to the power of 2 times 5. 3 times 7. 2 times 11. 23 is just a prime number. 24 is 2 to the power of 3 times 3. 5 to the power of 2. 2 times 13. 3 to the power of 3, 2 to the power of 2 times 7, 29, and 2 times 3 times 5. Okay. All right. So I did that on purpose to illustrate the process. So now let's go back and try to figure out the value for m. So m is the LCM of all of these numbers, right? So the LCM of 10, 11, dot, 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 all the way until 30. Okay, so now this is the slogan. You choose the biggest. Now you say, what do you mean by that? For each prime number, choose the biggest exponent. So for example, the first prime number is 2. What is the biggest exponent for which a factor of 2 appears? And it's right here. So that becomes part of the LCM. Next prime number is 3. What's the biggest exponent? I believe it's this one right here, 3. You got it? For 5, I believe it's this one, which is 2. And then 7, the highest is 1, or the biggest is 1. 11, also the biggest is 1. 13, biggest is 1. 17, biggest is 1. 23, 1. And 29, 1. So if you do this carefully, this is the LCM. For m, that's m. Got it? Okay, so now that you're an expert, the next part should be fairly straightforward. We now have to calculate n, which is the LCM of m, which is, I guess, what's up here, and then 32, 33, all the way up until 40. Okay, so the same thing. We've got m, so I'll just leave it up there, but I'll write all the other numbers, 32, 33, and so on. All right, so now let's figure out their prime factorization as before. So 32 is 2 to the power of 5, I believe. 33 is just 3 times 11, 2 times 17, 5 times 7. 2 to the power of 2 times 3 to the power of 2. 37 is just a prime. 2 times 19, 3 times 13, and 2 to the power of 3 times 5. Okay. All right, so here we go. Now let's figure out n. So n, same thing, think of the biggest. So for 2, my biggest, I think, comes from right here, this guy, 2 to the power of 5. So that's my biggest. 3, highest exponent of all of these guys for 3 is, I believe, 3 to the power of 3, which comes from this guy up here. Okay, just make sure I do this correctly. Next one is 5, and I believe that is this one. 7, I think the largest one is 7. 11, again, same thing. The largest exponent is 1. 13, largest exponent is 1. 17, 19, 23, 29, and I think there's another prime number in here, 37. Yeah. Okay, so now that we have painfully figured out n and m, let's put them on top of each other. So we got 2 to the power of 5, 3 to the power of 3, 5 to the power of 2, 7, 11, 13, 17, 19, 23, 29, and 37. Okay, so now m is 2 to the power of 4, 3 to the power of 3, 5 to the power of 2, 7, 11, 13, 17, 19, 23, and 29. Okay, so let's see what cancels. 29s cancel, 23s cancel, the 19s, 17s, 13s, 11s, the 7s. So this cancels and this becomes 2. This completely cancels, and then I've got this 37 left over all the way over there, and that is 74. And there you go. That is the answer, D. So I purposely did it the long way so that you can completely understand how this question is done. Therefore, number 8, the answer is D. Problem number 9. A right rectangular prism whose surface area and volume are numerically equal has edge lengths log x base 2, log x base 3, log x base 4. What is x? So we have a rectangular prism, basically a box. And as you all know, the volume is length times width times height. And the surface area, as I'm sure you all know, is 2 times the length times the width plus the length times the height plus the width times the length. Correct? Okay. Sorry, there should be width times the height. That's what I meant to say. Okay, so now they've told me what are the length and the width and the height. And I don't think it really matters which one we call what. So I'll just call that one the length, that one the width, and that one the height. So here we go. So they're saying that the surface area and the volume are numerically equal. So that means SA is equal to V. So SA, according to that formula, using these guys up here, it will be as follows. It will be 2 times the log of x to the base 2 times the log of x to the base 3 plus the log of x to the base 2 times the log of x to the base 4 plus the log of x to the base 3 times the log of x to the base 4. And the volume is just going to be the log of x to the base 2 times the log of x to the base 3 times the log of x to the base 4. Got it? Okay, so now we have to do some, manipulation, because we eventually have to figure out the value of x. Okay. Shouldn't be too much of a problem. We just have to use some log rules and all that stuff. So the first thing I'm going to do is going to divide both sides by log of x times the log of x times the log of x. Just basically this side right here. Let me just make sure I write it properly. And when I do that, what happens is that side becomes 1, right? But this side, it becomes a little bit different. It becomes 2 times 1 over the log of x to the base 4 plus 1 over the log of x to the base 3 plus 1 over log of x to the base 2. Right? Nothing fancy so far. Okay, now we have to use one of those log rules, and that log rule is that the log of a to the base b is equivalent to 1 over the log of b to the base a. And we're going to implement that rule up there. So that means this now becomes 2 times the log of 4 to the base x plus the log of 3 to the base x plus the log of 2 to the base x, and that right side remains 1. Now we use log rules to combine these guys because the bases are all the same. So that means this will be the log of 4 times 3 times 2 all to the base x. Right, it's coming together nicely. 4 times 3 times 2, of course, is 24. So we have log of 24 to the base x, and we got that 2 out front. And let's see, what can I do here? Now we use another log rule where you can put this 2 out in as an exponent. That's perfectly allowable. And therefore now we have x to the power of 1 is equal to 24 squared. And that's it. 24 squared is 576. It's a very good question. 576 is the answer, and therefore that would be E. Problem number 10. The base 9 representation of the number n is 27006000052. What is the remainder when n is divided by 5? Okay, first let me write out what is this number. So n is going to be 2 times 9 to the power of 10 plus 7 times 9 to the power of 9, because remember it's base 9, it's not base 10. And then plus, I guess, 6 times 10 to the... Oh, look at that. I just said it, and then I'm making the mistake myself. 6 times 9 to the power of 6, plus 5 times 9 to the power of 1, plus 2 times 9 to the power of 0. So whatever this number is, that's what an n is. Now, they want the remainder by 5, so we've got to use mod 5. And those of you that are not familiar with mod 5, or mod anything, basically, we're just talking about what is the remainder. So if I asked you, what is 11 mod 5? The answer would be, when 11 is divided by 5, what is the remainder? The remainder in this case is 1. Okay. So the good news about mod is that we can use powers of 9 to estimate. And let me explain. So we have 9 to the power of 0, which is just 1. 9 to the power of 1, which is 9. 9 to the power of 2, which is 81. Right? 9 to the power of 3 is 729. 9 to the power of 4 is 6561, and so on, right? So I'm not going to do them all. Let's just put them in 9 to the power of 5, down to the power of 6, 7, 8, 9, and do we need to go any higher? Yeah, one more. 10. Okay. Now I'm going to ask you, what is the mod of these guys? So if I said, what is mod 5 of 9 to the power of 1? Oh, sorry, 9 to the power of 0. Well, basically what I'm asking is when 9 to the power of 0 is divided by 5, what is the remainder? 9 to the power of 0 is equal to 1. When 1 is divided by 5, the remainder is 1. Got it? What about 9 to the power of 1? Well, that's 9. When 9 is divided by 5, the remainder is 4. Correct? And then similarly, this is 1, this is 4, and this is 1. So you can see there's a pattern here. 1, 4, 1, 4, 1, 4, 1. Got it? So that's what we're going to do now. We're going to just do the mod 5 of this entire number. And therefore, the mod 5 of this is going to be 2 times what happens when 9 to the power of 10 is divided by 5. What is the remainder? Well, according to our nice extrapolation there, it's 1. And that's what you put there. Got it? That's basically how you approach this question. So let's do it again. 7. Now we have to figure out the mod of this guy, 9 to the power of 9, when divided by 5, is 4, the remainder. Similarly, this guy, 9 to the power of 6, I believe is here, and that is 1. 9 to the power of 1, the remainder is 4. And then finally, 9 to the power of 0, the remainder would be 1 mod 5. And this is it. So this gives me 2 plus 28 plus 6 plus 20 plus 2. Add all these guys and you get 58. And then you have to do the mod 5 once more. 58 mod 5, the remainder would be 3. And that is the answer to this question. And therefore, that would make it choice D for number 10.